Hey everyone, this is Nicholas JMV, and today we're going to be talking particles in motion part 1, and we're going to be looking at finding velocity and the acceleration at time t. There's a lot that we need to talk about, and the first thing we're going to be talking about is notation. So when we talk about particles in motion, we're talking about the original function, position, the first derivative, and the second derivative, okay? And so when we look at it, position is going to be denoted as x of t or s of t. It depends on the textbook and the problem. Okay, velocity is denoted as v of t, but it also could be the x prime of t, the derivative of the position function. And same with acceleration. Acceleration is a of t, and this could also be the second derivative of x of t or the derivative of the velocity function. So a function, first, second derivative, and we're going to be looking at that. Now, these derivatives tell us a lot of things, some important ideas. Okay, and so when the velocity is less than 0, your particle, is actually moving left. When your velocity is greater than 0, the particle is moving right, and I didn't write it, but when the velocity is equal to 0, v of t equals 0, that means the particle is at rest. Some other important ideas here. When the velocity and acceleration, if they have the same sign, your particle's speed is going to be increasing. If your velocity and acceleration have different signs, meaning opposite signs, the particle's speed is going to be decreasing. And another big one here is when the velocity is less than 0, velocity is equal to 0 and your acceleration is not 0, the particle is momentarily stopped and it's changing direction. So the idea here is I'm kind of making videos on each one of these things. Okay, so hopefully they're going to be shorter and we're going to hit each one of these important ideas with an example. So I have only one example here to show you. Okay, so if the position of a particle at time t is given by the equation x of t equals t cubed minus 11t squared plus 24t, find the velocity and the acceleration of the particle at t equals 5. So what we need to do, velocity and acceleration, we need first and second derivatives. Okay, so that's what I'm going to do. I'm going to take the first derivative, and that's going to be x of t. Okay, and you can call that v of t, but I'm going to take x prime of t. Okay, that's what I've been given, and it's a power function. So I get 3t squared minus 22t plus 24. And they want to know, hey, what's going on after 5 seconds, right? So it's just a matter of a simple substitution of 5 in for t. So I go ahead and plug that in, okay, and this is what I'm left with. When I simplify this expression, I get negative 11. So what this tells me is that after 5 seconds, my particle's moving left because the velocity is less than 0. Now, the second part of this is acceleration, so x double prime of t. So now I'm going to look at my derivative and take that derivative. So I get 6t minus 22. That one's a little easier. But again, they want to know what's going on after 5 seconds. So just by substitution of 5 into that acceleration function, I can see what's going on. I get 30 minus 22, which is 8. Okay, so after 5 seconds, acceleration is 8. Notice how my velocity and my acceleration have different signs. So after 5 seconds, we would say that the particle is slowing down because these signs are opposite. So that's all I have on determining the acceleration velocity at a specific time t. If you have any questions or comments, type them below. We'll see you next time.